Hello everyone. Today we are starting a new series on MPLS and segment routing, basic to advanced. And this is our first session where we will be talking about MPLS introduction. So today's session will focus on some of the general and probably not so widely known things about MPLS that we will be looking at. And in the subsequent session, we will open more aspect of MPLS and then we'll be moving to segment routing as well. So today's session is for the absolute beginners, but it's my belief that even some of the experienced user will find it useful as well. So feel free to watch at a 2x speed. And I'm pretty sure you will get something new in this. So the agenda that we will be talking is just understanding some of the general MPLS aspect. With that, my name is Sunil Pareek and let's just jump into our discussion for today. So what is MPLS, by the way? I will talk about the historical journey of MPLS, but before that, I got the opportunity to work on MPLS somewhere around 2007. It was for a very large SP, and our task was to migrate from frame relay to MPLS. And do not worry if you hear this word frame relay for the first time, because after this session, I will not even talk about it. This is something that was legacy, not used anymore. But there were some key learning lessons in this journey from FR to MPLS that, of course, we will discuss in this series. And like any change, which sound a bit complicated at the start, MPLS was no different for us back then. We were a tier 3 service provider at that time. So I was working for this company and we were migrating our customers' network towards MPLS. And that's how we used to call it at that time, that probably MPLS is one of the most painful learning for SPs. Because at that time it was a big paradigm shift for us from a IP or layer 2 based forwarding to a label based forwarding. I will talk about this journey in this session as I was saying earlier. And then we will also look at how very soon this painful became one of the pleasant learning for SPs. So with that, I also want to burst some of the myth around MPLS. And whenever we talk about the benefits of MPLS, one common thing, even in some of the interviews also that we hear, that MPLS based switching is much faster than IP based forwarding. In today's time, where control plane has been separated from forwarding plane, where in the control plane I can have my IGP, which can be OSPF, ISIS, EIGRP of your choice, which actually learns the control plane information and then forward the information to this forwarding plane, and then this basically get programmed. And all this forwarding these days in most of the hardwares happens in ASICs. And these ASICs are capable enough to forward a IP based packet much faster, even at a line rate. Does not matter whether you are going at a 40 gig or 50 gig speeds, right, which are becoming more popular these days, even 100 gig also. So saying this, that MPLS based switching is faster than IP based forwarding, it is actually a bogus benefit. If somebody is deploying MPLS just for this reason, that's a bogus benefit. Before we get into the MPLS discussion, I want to highlight one more important thing with MPLS, and we will build our story around it. So, MPLS, for those of you who are not familiar, the MPLS packet looks like this, where there is a 20-bit field which is for label. This label is literally a number. It can be 20, 30, 35, 40, anything. Then I have something called as 3-bit, which was initially called as EXP, and then later on it was converted to a traffic class. So this is a 3-bit field. This is used for QoS. I have 1 bit reserved for bottom of stack. Don't worry if you don't understand this, we will talk about it. And then there is another field which is TTL, that is 8-bit field. This is it. This is your MPLS packet format that got inserted between the transport layer and your layer 2 frame, right? So somewhere it comes, and then routers basically forward the packet based on this 20-bit field. Without getting into any of the complexity, there is just one important point that I want to highlight as a part of this. I'm not sure whether you guys have noticed it or not. In this entire MPLS packet, there is no protocol field. Pause this video and look for an IPv4 packet format, and you will see that there is a protocol field which actually tells the layers up and down that what exactly the payload is being carried, whether it is TCP, UDP, all that. But if there is no protocol field, that means if you capture a MPLS packet on a wire with the help of Wireshark, there is no way to tell what type of protocol it is carrying just by looking at that label. So the protocol field is not there. But what could be the advantage of it? The advantage here is that with this MPLS based packet, your payload that you are carrying can be literally anything. It can take even a layer 3 packet, layer 2 packet, or even let's say layer 1 also. If somebody want to search more, just look for GMPLS, right? So that is the advantage, and I will come back to this later in this module also. But for now, Think of MPLS as a unified forwarding technology solution which was designed to carry almost anything in a service provider network. So service providers, they just need to enable MPLS in their core network and they can provide any services on that unified network architecture. From the historical perspective, the work on MPLS started somewhere around 1997, and just because of the benefits that we will talk. In fact, one I had given you a hint in the last slide. We will open it up more, but that has helped MPLS to evolve into exotic technology to a mainstream solution. Rapid deployment has been seen for, for MPLS enabled services. Right? I have already told you if somebody is deploying MPLS just for the speed because labeled packet can be switched faster, no, it's not a benefit. It's a bogus benefit. But the real benefit is this, and we will focus more on this in our few lectures. And one more idea that if I wanted to give you, MPLS and IPv6 in these industrial bodies, they started their journey almost at the same time. But do you guys know when was the first MPLS VPN customer was deployed? It was in 1999. And for IPv6, we are still struggling to enable customers, that convincing them basically to deploy IPv6. Now even there are some government mandates are coming and mandating this. If you ask me, the key difference was the business reasons. MPLS, there were very strong business reasons. We will explore that. IPv6, those business reasons are coming now. So that's why MPLS was deployed much before and deployed at a much faster pace. So basically, when these industrial bodies, this IETF, they were drafting a solution for a new forwarding architecture, which was later became MPLS. They wanted it a very efficient and a scalable solution. And they looked at multiple aspects of it. And to cut short my story on this, they looked at a layer 2. Normally at layer 2, you see efficient forwarding. A switch basically does a lookup on the MAC and send the packet is considered very fast. And that time there were these frame relay and ATM based layer 2 forwarding solution which even supported traffic engineering, which was, by the way, not that easy with IP based forwarding. So they took this efficient forwarding or these traffic engineering aspect of these solutions, the good points basically from layer 2, and from the layer 3 they took some of the good points like scalability. Another one point was flexibility. Right? Your layer 3 network is very much flexible. They took the best of both the world and they came up with MPLS. And if I give you the reference from OSI model, people debate that MPLS fits somewhere around 2.5 layer. So it is actually the best of both the world. And on the forwarding plane perspective, if you are somebody who does not understand MPLS at all, just consider that the forwarding happen based on the labels. There are these numbers like 20, 30, 40, 50. Router will look at it and swap it with, let's say, some number 200, 300, like that, and forward the packet. That's it. And these packet, as I said, there was no protocol field initially. That means payload can be layer 2, payload can be layer 3. And another misconception that I see in people around MPLS, that MPLS packets are switched, they are not routed. This is very important. We will open it up further, but for now, just remember that the packets are getting switched. Let's just look at some more aspect of MPLS labels. And in this slide, there is a lot of text and a picture also. So let's just first look at the text side. So it is purely a label based forwarding. We are moving away from IP based forwarding. There is technically no limit on the number of labels. Any number of labels can be put on a packet. However, there are some hardware limits that exist. We will talk about that. And it's the outer label that is always used for forwarding. Don't worry about this point. We will talk about it later on. Initially, as I shown, this is how your MPLS packet looks like. And if this is the only label on a packet, right, there is only one label, then you will see this bottom of stack bit as 1. If there are multiple if there are multiple labels, then the inner packet will have this value set to 1. What does it mean? It means that when this bottom of stack bit is 1, right after this, your payload will start. Now, I'm talking about this label, I'm talking about this forwarding decision. Let's just look at a sneak peek at a very, very high level. Let's say some 30,000 feet view of MPLS based forwarding. And this is again for my beginners. Advanced users, they can just fast forward it. Let's say somehow for an IP based destination, which is on this side, the labels are allocated. We will talk how that is being done, but for now, you assume that the labels are allocated. And then we are sending a packet in this direction. So this is our packet direction. So here this node, by looking at that the core network, like this network is enabled with MPLS, what it will do, it will push this label L1 on the packet and send it here. This node will simply look at an incoming label which is L1 and swap it with the outgoing label, which is L2, and forward it in this direction. This device will look at this packet, swap it with this packet and send it in this direction. And then this guy, because there is no MPLS here, this will look at this label, pop it off and send it in this direction. I know it is a bit more complicated than what I have just talked, but remember, this is 30,000 feet view. But here again, one important point that I want to highlight. This guy will look at L1 forward, swap it with L2 and forward. This guy will look at L2, the incoming label, swap it with L3 and forward. None of these nodes will look at this payload at all. That means this payload can be anything, as I said initially. Right. So now that we have talked about some very basic aspect of MPLS, we will open it up further. But the benefits of MPLS were so good that I can challenge you to find even a single service provider on this planet who does not use MPLS. Even when we were evaluating this technology in 2007, there was a strong recommendation from all our vendors, these product-based companies, to move to MPLS. It has enabled so many business use cases for us that I will talk in our subsequent series of these sessions. But one question that I normally get is, does MPLS only rule the SP networks? If it was so good that all the SPs or almost all the SPs adopted it, what happened when it tried to penetrate it into data center or enterprises? Why it was not so successful? So this is one common question that I normally get whenever I talk about MPLS. So I thought of talking about this in this video as well. Though we have talked about it in our monthly webinar series videos also. So here in our networking world, the overlays basically rules. There are so many type of overlays that exist. Your ACI, SDXS, even GRE, MPLS, layer 2, layer 3 VPN, they are all some form of overlays. When I have so many of these overlays, which overlay is good for my network? Or let's say I am having a data center based network. Is MPLS based overlay network is good for me or not? Right? So to answer this, overlays solve a big connectivity problem, but which one is good for DC, or whether MPLS is good for DC or not? This, like we used to say for anything in networking, you ask any seasoned architect for some advice, and probably in 90% of the cases their response will be, it depends. So there is no one right way, there is only your right way. Having said that, let me put some thoughts on the table that why DC network did not adopted much on the MPLS side. Right? So MPLS in data center, why or why not? First, let's look at some factors which were in favor basically. So MPLS was already there on the WAN side. MPLS supported multi-tenancy, and in data center, this is one of the key requirements. So MPLS was supporting multi-tenancy for SP for quite some time. MPLS can seamlessly integrate with existing network, or even when the WAN was MPLS. It was initially seen that having MPLS in the data center can provide a seamless integration there also, right? But then when data center operator actually started evaluating it, there were some factors which were against it also. And leaving all the technical aspect out, any technology, first its use cases are evaluated. And for MPLS, one of the big use case was traffic engineering, which was not even applicable to data centers. If you look at a service provider, based on traffic engineering, there were many business use cases that we will talk in our subsequent series of sessions. But when traffic engineering use case was being evaluated by data center admin, there was literally no need for that. Data center, like in the fabric, we say there is enough bandwidth and very low latency. That's how they design the data center fabric. So there is no need of a traffic engineering based solution. So if one of this big use case was a big no, then suddenly there were some more overlay technology solution which came in the queue and were ahead of MPLS in terms of advantage, because some of the benefit of MPLS were ruled out. And one such overlay solution was VXLAN, which was simply IP based forwarding, and data center admins were very much aware of this. Every hardware, unlike MPLS, supported IP based forwarding. So, to conclude this, reason for not penetrating into the DC for MPLS, because not all the benefits were needed. So with that, let's just conclude our MPLS general module here. I hope this was informative for you guys. And thanks a lot for viewing. I will see you in our next session with little more depth on MPLS side, and then towards segment routing as well. Thank you.